I'm a student from UC Berkeley, and I'm taking the CS61B course. I have just finished a project. This project is called NBody. It's about simulating the moves, the positions, the velocity of planets in a galaxy that they exert force on each other, the gravitational forces. And my implementation includes a new feature is that it supports elastic collision. Let's see how this works. We'll run this file. I created two Java files. They are called nbodyextreme.java and bodyextreme.java. Let's first run the Java C, then run the Java, given some parameters. We first run the atom.txt given these parameters. We see that when these two atoms get close to each other, they will get stuck to each other because in the elastic collision, when they get close to each other, if they do not get enough force to get away from each other, the gravitational forces between them will become very, very large, so they will just get stuck with each other. To solve this problem, we have several possible techniques. For example, we can increase the amount of dt so that when they collide with each other, they will have a better have a larger force to get away from each other. Let's try that out. Now we see that these atoms are less likely to get stuck with each other, but this problem still occurs. Well, we can try a different example. This example is called hypnosis. Well, in this example, we can see that these planets perform in a very interesting way. Like we can see that this planet comes back and it collides with the sun, and we can see very clearly a sense of elastic collision here. And I think that planet will possibly come back again if we choose a larger dt. We'll try that out. Yes, we see that the planets keep colliding with each other, and we can see some characteristics of elastic collision very well here. Let's run that again. Well, probably many parameters in this program can be adjusted so that the simulation is more close to the real situation. For example, there are two parameters called the tolerance upper and the tolerance lower. And when the distance between two planets are between tolerance lower and tolerance upper, we will decide that the two planets actually collide, and we will use the formula for elastic collision to update their velocity and distance. Of course, this version of code is still quite simple and trivial, and much like greater advances can be done to this version of code so that our simulation looks better and also is more close to the real situation. Thank you.